Good day to you all and welcome to this Motek webinar. My name is Dwayne Mitchell and I work at the Motek Research and Development Centre in Melbourne, Australia. The topic for today's webinar is helpful hints on communicating via CAN. So we're going to cover a few subjects that haven't been covered in some of our other Motek webinars. I'll just quickly give you a brief synopsis of what CAN is. Then we'll look at the Motek devices which use CAN and what the functionality is with CAN. We'll just quickly give you a reminder of some of our other webinars on CAN topics, because largely we're going to be trying to cover some information here that isn't in our other webinars. Okay, then we're going to look at some of the commonly available USB to CAN adapters, including our own. Then how to set up our PC software to work with our own adapters. Then we're going to have a look at how we can use the inbuilt diagnostic tools within our dash loggers if we're trying to solve CAN communication issues with those devices. Then we're going to take a look at how you can help us to get specific CAN data so that we can modify our products or develop new products that can work with your particular application. And then finally, just a brief look at some of the useful tools that we use here at Motek and that you may also find useful. So we'll just go over the basics of what CAN is before we get in too deeply. So CAN is an acronym that stands for Controller Area Network, and this is a modern communications bus that's used on a lot of vehicles. It differs from some of the older communications buses such as RS-232 in that it is a multi-drop network, and that means that you can have multiple devices all operating on the same CAN bus at the same time. So it's a high-speed network with multi-drop capabilities. It's effectively analogous to a local area network on a PC system, a LAN, where you can have multiple devices all connected at the same time. CAN uses differential signaling, and what that means is that it allows us to have high immunity to things like RF interference, which typically comes from things like magnetos and other ignition system devices on most vehicles. So differential signaling uses two wires, and it allows you to eliminate most of the noise in your signaling, and that gives you very high speed and very high reliability. Now, CAN systems have a lot of background functions that we as the users aren't aware of, and we don't need to be aware of them. So the CAN system is not only an electrical specification, it also specifies how the subsystem will manage the data. So we as users don't need to manage the data. The CAN subsystem manages the data, and that means it packages the data, it looks after the error checking and error correction, and it looks after making sure the bus population all behave in the correct way and that the bus does not get overloaded. Okay, so now what we use CAN for is to transmit data from one device to another, and it's used typically for both input data and control data. So input data is in the form of things like channel values like throttle position, RPM and vehicle speed, and control data is typically such things as fuel pump control, rain light control, gearbox control. Both types of data can coexist on the CAN bus. As a matter of fact, the CAN bus itself does not care how the data is used. It is simply a transfer system. So CAN works like cable TV, where again we have a multi-drop system, and that allows one device to transmit data which can be received by multiple devices. A typical example of this would be an engine ECU that might transmit something like throttle position and road speed and engine RPM, and then you may have multiple devices hanging on the CAN bus, for example dashboards, gearboxes, brake, ABS controllers and so forth, and each of these devices will be looking at this data because they may all find engine RPM, for example, or road speed to be a useful piece of data. So it's a broadcast system where multiple devices can transmit and multiple devices can receive. As I said, we don't specify in the broader CAN specification how data is used. CAN merely is a packaging system that takes your data from you at one end, delivers it to another device at another end. And what the composition of that data is not of interest to the CAN system. So the user determines how the data is packaged and also how that data is interpreted. Of course, with a Motek scenario, most of our devices have predetermined packaging for the data. We call this templates. And so, for example, our ECUs and our dash loggers can communicate with each other very simply using the predefined templates that come with the system. So you don't need extensive knowledge on these devices to make the CAN communication system work. If you use the supplied templates, you can get things plug and play in a very short amount of time. Okay, now there are a number of Motek devices that use CAN. As I've said, CAN tends to be a later communications system compared to such things as RS-232, and so virtually all of our current product range use CAN. Anything that's been introduced in the last 10 years will have CAN capabilities. Now what you can see here is a quick split of our ECUs and our dash loggers and a couple of our other devices. Now our earliest ECUs, M4, M48 and M8, are not CAN capable. They have no CAN functionality whatsoever. So as you can see, they're in these 5 categories that we often use CAN for. The M4, the M48 and the M8 have no capabilities at all. Our 100 series ECUs, which means our M400, M600 and M800, do have CAN capabilities. They were introduced in 2000 and they cover a lot of possibilities with CAN. So for example, our current ECUs, CAN is used in fact as the setup protocol, which is how the ECU communicates with the ECU manager program on your PC. CAN is also used for data exchange. That's of course its principal purpose. CAN is not used for GPS receive, but our M800s use RS-232 for GPS receive, which is the most common form of GPS system. CAN is used for log downloads and it's also used for telemetry. Now the M84, which is a entry-level version of our M800 series, shares the same capabilities as the M800. So these are very powerful tools and they have a lot of CAN capabilities. Now our dash loggers, we have 3 generations of dash logger. The earlier generation ADL and SDL, they use CAN in fact for all of these capabilities. You can receive GPS on CAN in our dash loggers because there are 2 GPS specifications, one for serial and one for CAN. So you can use GPS for CAN receiving if you have a GPS device that happens to use CAN. I mean, most of them are RS-232. Our ADL2, which is our 2nd generation dash logger, has the same capabilities. It communicates with the dash manager program via CAN or USB, and it also is used for GPS receiving, for exchanging data, for moving logs, and for telemetry. Now in this case again, the ADL and the ADL2 both can communicate to the PC by USB or by CAN. Normally we find log downloading is actually faster via USB. Our latest generation of dash loggers, the ADL3 and the SDL3, they communicate to the PC via Ethernet. So that means that CAN is not used for the setup program, for the dash manager program, and it is not used for the log downloads. Ethernet is used for both of those functions. Of course, CAN is used for data exchange again on these dashes with ECUs and so forth. They do have the GPS capability, and they can be used for telemetry as well via CAN. So the only difference here is that the download and the PC communications are done via Ethernet. Now, 2 other devices that are extremely useful in our current product lineup, the PLM, the Professional Lambda Meter. This is a device that works with multiple lambda sensors for wide range lambda measurement, and this communicates to the PC program via RS-232, not via CAN, but it can transmit CAN data for data exchange into things like dashes and ECUs. And it doesn't have CAN capabilities for GPS, etc. It's simply a source device for CAN information. We do have another Lambda device called an LTC, which is specifically for CAN. So this is a device that has a setup program which works via CAN and then uses data exchange via CAN also. And another new device, we have the PDM, the Power Distribution Module. This is a very powerful control system that's used for things like relays and loads, lights and starter motors and so forth. And again, this is communicates via CAN almost exclusively. So that's just a quick look at some of the Motek devices that normally use CAN. Now, as I mentioned, we have done a number of webinars on CAN topics, and the objective of today's webinar is just to cover a few of the smaller side issues, if you like. This is meant to be a fairly brief webinar. It's just about subjects that haven't been covered by some of our other webinars. As you can see, we've done 4 other webinars on CAN messaging. The basic one, what is CAN? Then we've got some specifics on setting up data sets in ECUs and dash loggers. We've got a very good webinar which covers all of how the CAN system works in our power distribution modules. And then there's a generic explanation, if you like, of how all of our different CAN message types work. So I would suggest, if these are the things that you're interested in finding out, that it's worth having a look at these webinars even before you proceed any further with this one, because those webinars have very extensive information. And again, all we're going to cover today are a few of the lesser issues and a few side topics that people may find of interest. Okay, so the first thing that can cause some grief to our customers is how they get CAN information into their PC or into their laptop. Now, it needs to be stressed that Motek devices will only talk to PCs via our own USB to CAN and parallel port CAN cable. There's a photograph of our USB to CAN adapter, which we call a UTC. And this is the current generation device. Just plugs into the CAN port on your vehicle and then has a USB type connector into the PC. So virtually, as I said, all of our current manager programs, ECU manager, dash manager, LTC manager, PDM manager, they can all communicate with those devices through this UTC adapter cable. Now, this is not an open source device. It has Motek's proprietary software in it, and only Motek software is capable of using these devices. So it's not a general purpose CAN bus analyzer tool. It is a unique communications device to allow PCs to communicate with Motek products. Now, normally when you install these products, for example, ECU Manager for the M800, the device drivers are automatically installed for such things as a UTC. So in normal terms, when you buy something like a Motek M800, you need to buy UTC as well, so you can talk to that device. And when you install the ECU Manager program, it'll install all the required drivers. And all you simply do is install the Manager program, then you plug in your UTC, and then you can start communicating with your M800 or your Dash, whatever the particular application is. Now, there is an older CAN cable which we call our parallel port CAN cable, and this plugs into the older 25-pin plug that's found on many desktop PCs, what we would call legacy function. So not necessarily available on most modern laptops. They usually have USB only. If you need to use the parallel port cable, it will communicate with virtually all of our Motek products, but some of our newer products will not use the parallel port CAN cable. They will only use the UTC. So if you need to use that older cable and the driver hasn't been installed, then the simplest way is to install our ECU Manager M800 version 2.11. This includes the correct driver, which is called can211.sys. That's a system file, and it's kind of messy to install this manually, so we just normally install the ECU Manager version 2.11, which is an earlier version of ECU Manager, not recommended for our current. Our 3.5 ECU Manager actually is a much better system, but this will automatically install the CAN drivers for our parallel port CAN cable. Okay, so just to remind you that there are other devices, many of which we use here at Motek for analysing CAN information, and there are some that we'll cover later in this webinar. Most of these devices, such as the CAN capture or the CANalyzer and various OBD tools, are very useful for monitoring CAN bus traffic, but they don't interact with our Motek Manager software. So you can't use them, for example, with ECU Manager to communicate with your M800. You must use the UTC or the parallel port CAN cable. Now, as I said, UTC, our normal USB to CAN adapter, is almost always functional just by installing the ECU Manager software or the relevant software for the device that you have. Now, if for some reason As time passes, of course, these things be changed and updated occasionally. Firstly, I suggest that you download the current version of the software for your Motek device from our website, because they will always contain the current drivers as well. And these device drivers will work on any version of Windows, XP, well, from XP onwards, I should say. So that means Windows XP, Windows Vista, Windows 7. And again, if you have a Windows XP laptop and you have issues, then once again I suggest you download the current version of the ECU Manager program or the Dash Manager program, reinstall it, and it will update the device drivers as well. Now, in some cases there can be issues. It's quite simple to go into the control panel on your laptop or on your PC and to reinstall the drivers manually. So this is normally done by, firstly, depending on which operating system you're using, you go into Control Panel and you need to launch the Device Manager. In Windows XP, that's what we're showing here. You go Control Panel, then you click on the System icon, the Hardware icon, and then the Device Manager tab, I believe, and that will open up. Sorry, it's the Hardware tab, and then it's the Device Manager button. That opens the Device Manager. That program shows everything that is the hardware that is on your laptop or on your PC. And if there is a clash with your UTC and the USB driver is not working, normally you will see a yellow question mark next to the UTC. In some cases, it won't appear in the correct tree position in your device manager, and in that case, it may appear just as a listing of an unknown device. So sometimes you need to scroll through the device manager list and look for unknown devices, because that may be where the UTC is appearing. Normally it would appear under the Universal Serial Bus Controllers drop-down, and then it'll just be called Motek UTC, and if necessary you can right-click on that designation and select Update Driver, and then you need to tell it not to automatically update the driver, but you need to browse the computer for the particular location of the driver software. This is fairly important. Again, with different operating systems, this little process works slightly differently, but the main thing is to tell it that you want to manually select the location of the driver. Now, the driver will always be in the directory I've shown there in point number 4, and that is in C /program files /motek /comms /1.0 /USB drivers. So you navigate through to that directory and click OK, and then reinstall the driver. Now, we did have an issue for a year or two which has been resolved with our current drivers, but in the event that you have a 64-bit operating system and the driver is not working, we do have a downloadable file on our website which you simply download and execute that file, and it will install the driver as I've just mentioned, but it will automatically do all of that for you, and that allows for 32 and 64-bit versions of Windows. So just follow that link onto our website and you can download that from our download section. Now, the other thing that must be up to date, if you've installed the correct device driver for the UTC device, it's also very important that you update the firmware in the UTC. Of course, when these are shipped, they have the current firmware in them, but if your UTC is more than 1 year old, I would seriously suggest that you update the firmware that's in the UTC, because our later firmware covers a lot more possibilities and is quite significantly different to the earlier firmware. So you need to do that simply by going to your Start menu on the laptop or the PC. You select All Programs, then Motek, then USB to CAN adapter, and then there's a selection there to upgrade the UTC firmware. So as you can see, the current firmware version is version 1.13, and you should go through that Start menu selection there, and if it doesn't show version 1.13 in your own laptop, then you definitely need to update the drivers and install a newer version of ECU Manager so that you can put the correct firmware into the UTC. Okay, now all of these things we've discussed can be the cause of some grief for many of our customers. So although this all seems fairly evident, that's why we've gone over it, because in many cases we do have support phone calls where people have simple problems like the ones I've just been through, and we have to manually talk them through how to do all of these things. So I certainly would suggest that you make sure that all of your drivers are current and that your firmware is current and you should avoid needing to make a support call just on the basis that you've, for example, gone to a new laptop, installed the software you had on your old laptop, and it won't work with your M800. This is normally because you've got older version software from your old laptop and you need to get our current software off our website. Okay, now we're going to have a look at how people can resolve CAN communication errors in our dash loggers. This is something that the dash loggers have a small, let's say, level of diagnostic help that's available to you. I wouldn't say it's extensive, but it still can be sufficient to find out why for example, your ECU is not communicating with your dash logger. Now, dash loggers in each of the communications slots, what we call the slots, they have you designate what particular template you're using, or you specify your own CAN template using the advanced functions. But in many cases, all you do is click the select button, and then you can select a CAN template for something that you already know how to use. So here I have the select button here, and often you just click that button and then you pull down the menu, select what it is you need to receive, for example, an M800 data set, and then everything is done for you. What you can see here is this is just some Lamborghini stuff, and in this case, these are individual templates that we've built to work with a particular car. So these are all built using this advanced function. So firstly we click on advanced, and then we build ourselves our CAN receive information. Now, amongst the options you have with this, of course, is how the receive channels are defined. But on the first screen, which is shown here on the right, the normal first tab you have is the parameters tab, and you can see over here what we've put in is a diagnostic channel for this CAN slot. So normally each CAN slot has a number. For example, this one here is called CAN slot 3, and over here I'm editing the CAN3 comms setup, and so my diagnostic channel is called comms CAN3 diagnostic. It would be a little bit silly to give it a different name, and normally when you select the select button, it just pulls up the same name as the slot you're in. So clearly that will save you some time when you're trying to monitor the CAN information. If you've got a CAN slot name that matches, you can choose something else, but it wouldn't be terribly practical. Okay, so that's how we add this diagnostic channel. Now the point here is that this is not automatically added to your CAN receive slots. It's only there if you've manually selected it. So that's why it's important when you set up your CAN templates that after you've defined all your CAN channels and your receive information, that you add in this diagnostic channel as well. It does, of course, occupy a little bit more space in your logging, but it's very, very useful for you to be able to see. You can bring the logging off the vehicle and see if and when the CAN system has been behaving or misbehaving. Okay, so that's pretty straightforward. Of course, you then save that and send that configuration to the dash logger. Now, the reason for these diagnostics again is that you can either view them in real time using the monitor channels function, as long as you're connected to the PC, of course, and you can also log them for later analysis. If you wish to, of course, you could also put them on the dash display as well, which means you can see the CAN error statuses whilst the vehicle is running without being connected to a PC. Normally we would only do this sort of thing while we're trying to eliminate CAN errors. It's not terribly useful for the driver to be able to see such information. Okay, so if you are in the monitor channel screen on the ADL or SDL manager program, what you'll see is these CAN diagnostic codes. They're shown in decimal in the dash logger, so that's the decimal code on the left-hand side. There are a number of codes which allow us to establish what is going on with the CAN bus. Now, firstly, there's a couple that you virtually never will see, and that would be code 2048 and 1024. These relate to E888s, and in general terms, they're not going to be particularly useful. If you are monitoring this CAN status, the one you will see almost always is error number 512, and that simply indicates that there's no CAN message coming into the system, so therefore your transmit device is not functional, or there is some other bus clash that's not working. Now, in most cases, if there's a bus clash, what that means is that there is either multiple devices on the bus, or there is, for example, two devices running with two different data bus speeds. you'll get a clash which generally comes up with a different message. Normally the bus error message is the one that comes up. So you will see, for example, these first messages 16384, 8192, 4096. These are the messages that usually come up where there are many bus errors. So firstly, you'll get 4096 once there are more than 96 errors on the bus. If there are more than 255 errors, the bus actually is disabled and you won't get any CAN data whatsoever. So again, this is typically caused by either more than one CAN transmit device trying to use the same channel, or two different devices trying to communicate at different speeds on the bus. The bus can only operate at one speed. Now, if you do see the bad config, this is usually because there's a device specified which uses a CAN address which has already been predefined as a Motek reserved address. Okay, now this is typically addresses like 5F0 hexadecimal, which is the address we use for our dash logger data sets. So if you've defined a different address that's at the same on the same number, then you will find sometimes you'll get this bad config error. The other thing is that when your Motek devices are communicating with a PC, they use another set of reserved addresses to exchange data. So you can see, for example, this monitor channels on screen. So you'll actually use another set of CAN addresses, and this is often in the region of 200 hexadecimal. And so if you have for example, some Ducati dashboard systems use some of the addresses in this same area for their dash communications from the standard ECU to the standard dash. And this would come again with this sort of address clash. Now, if this is the case, what you need to do in your dash logger is go into the options menu and change the CAN communications settings so that it uses secondary CAN address instead of the primary CAN address. And what this does is it clears that reserved space around that 200 hexadecimal area, and it allows other devices to use that space. So that's the principal reason you'll see this error number 256. So again, the most common ones you're going to see are 512, which just means there's no CAN data actually valid on the bus, or 256, which means there's an address clash. And in some cases, you're going to see 4096 or 8192, which means that the bus is effectively misbehaving and may well shut down soon. The one table value I don't have here is 0, and that means that the bus is working properly and that you do have CAN data. Okay, so now we're going to look at how you can get CAN data in a form that Motek can use to help you. So this is very common with the original equipment type installations. For example, we have things like our OEM kits for Mitsubishis and for Subarus, and we also have many OEM kits now for our PWCs, and we're now doing snowmobiles. So each of these is a system where there's a standard onboard communications CAN system on the vehicle, and then we've added a Motek device, either an ECU or a dashboard, into that standard system, and therefore the Motek device needs to be able to function correctly with the original CAN bus on the vehicle. We also do these things for such things as V8 General Motors engines and a few Ford engines, and this allows us to run our dashboard straight into the standard CAN buses on these cars. And we also have ECU kits that allow us to do the same sort of thing. So the point here is that we need to see the data that's on the original vehicle, and then we need to establish which parts of those data are going to need to be generated by the Motek device, or which bits of those data need to be examined, for example, by a Motek dash logger, so that we can use the original engine data and display it on our dash. Now, this is a task that we perform here at the Motek R&D Centre in Melbourne. Each of our distributors and dealers have some of these capabilities, and generally, if there is an issue that needs to be resolved, we can send CAN test equipment to our dealer or to our distributor. They can put it on the vehicle in question, and we have a number of tools that allow them to collect data for us, and then we can analyse that data. Now, the tool we use is called a CAN capture tool. There's a little photograph of one of these devices there. It's a very powerful tool, and we can supply that to the dealer with a straight application that's already written. They simply plug that into the OBD socket if there is one, and that will record all the CAN data on the vehicle. So this is a very simple tool for the dealer to use or for the customer to use. It doesn't offer you the capability to analyse this data yourself. It's simply a way of collecting the data so that we here at Motek can have a close look and determine what needs to be done. So again, the point of this is that we can look at the original equipment CAN messaging for such things as engine computers, dashboards, ABS systems, stability control systems and such, and then we can devise Motek products which will interact with these OEM systems and work correctly and not bring up any fault codes and such. As I mentioned, if the vehicle has OBD2, we just simply plug this test device straight into the OBD port. Some cars have all the CAN data on the OBD port, which means you can get the body computer, the ABS computer, the engine computer and everything all on the OBD port. Some vehicles have multiple CAN buses, and that means that there's only generally the engine ECU data is available on the main OBD plug, and it may not be possible to get such things as the ABS computer on that plug. We've also seen situations, for example, with Aston Martin, where there are actually two OBD plugs under the driver wheel, and one of those plugs gives access to some data, and the other gives access to the body data. So in this case, you actually have to log both buses. It gets a little bit complicated. Nonetheless, the point here is that we can devise new Motek products to suit once we have this data collected. And we have a very simple test procedure for these things. You more or less plug this device in, run the application on the laptop, and then you go through something like the sequence you can see here in this table. This is just an example of what we might do, and it allows the customer or the dealer to simply follow this step process, activate each of the things that we're interested in seeing data for. For example, here we've got brake pedals, throttle pedals, steering and so forth, and these are typically the sort of things we need to get from a standard vehicle bus that we can then display on our dash loggers. Now when you press the brake pedal, there may just be a switch or there may be a brake pressure sensor, and so this is how we know when we look at this data log, we can tell from these timestamps just when various things happen. So you can see it's not a terribly complex process. Generally it only takes a few minutes of testing on the vehicle. You can email us these log files and we can have a look. And in some cases we can email you back a test program that will actually run some of these functions or display functions on the dashboard before you send us back the test equipment. So this is a thing we've been doing now for a year or so, and it's a very functional way for us to add capabilities to the current range of Motek product. Now I would stress that if you need to do this, don't contact us, contact your dealer. The dealer can contact us and we can arrange this through the dealer. We will not do this directly with customers, we will only do it with dealers. So as I've said, we can use this test data to make CAN templates for dashes, and we can also develop things like our Sea-Doo products or our other jet ski products where our ECUs produce the correct CAN information to operate the standard dashes. Now the Sea-Doo is a very good example of that. These are the current 2010 Sea-Doo models have an integrated brake system which has a brake lever on the left-hand handlebar, and at this time Motek is the only aftermarket manufacturer that can operate all of these systems correctly. So we've analysed all of the brake and engine data. We can operate the dash correctly, and we can also operate the brake system. And so we have a competitive advantage here, and this has taken quite a bit of analysis using some of the tools that I've demonstrated. Okay, so now here's just a summary of those tools. Now the first one I'm showing is the one that we use here. Now we do have another system which is called a Canalizer, which is made by Vector in Germany. These are extremely expensive test tools. Of course, we suggest you would use them if you needed to, but they're in the vicinity of about $8,000 US. So it's a very powerful tool. What we're showing here is the one that we use here quite a lot, as well as the Vector Canalizer. This one's called an Ecom Can Capture, and these retail for about $1,295 US. So if you need to do this sort of work yourself, there are two options. We can loan you one of these for a very short period of time. We don't have too many of them. Or if you have a lot of this sort of work to do, then I'd suggest you just go to their website and buy one. It's a very, very powerful tool. Now these screens just below, they're not in terribly good detail, but what you can see here, this is just a picture of the device itself, just plugs into the USB port, and then it comes out to a CAN adapter of various types. We normally rewire these with a different type of plug. We just put DTM plugs on them. So this just installs on a normal laptop. It only logs CAN data while it's connected to the laptop. But in fact, we use little $300 netbooks for this sort of thing, and you can even run them in boats or in jet skis without any problems. So this has a general purpose collection screen. This shows you the raw data as it's coming, and it gives you a timestamp, shows you various things like the address and then what the actual data is, and this will just scroll along with the data as it's running. Then we can also have predefined variables that we've discovered, and this will show us, this is in fact off the CD that I mentioned, shows us the brake position, the brake lever position, engine RPM and so forth. Now this is data that we have defined because we've used this tool to work out where the data resides and how it works, and then we can convert this into real numbers, and we can display these real numbers as well. Now on the left here is a picture of how this system works. It's a very powerful graphical interface where you basically can add modules or components, wire them together with these green lines, and then you can have various functions available to you. Now once again, we actually can produce an application from this system that you don't need to understand. You simply press the start button and it will run, but in the background it's running some sort of scripting language like this. We can actually write C code for this as well, so it's an extremely powerful tool. I couldn't recommend it highly enough. Okay, now there's a few other tools that you'll find quite useful. This is one we've mentioned in regards to RS-232. This is another tool, a very inexpensive tool, $150 US. They just plug into a USB port. Now this one does have some limited capabilities. It's not a long-term logging tool. It's more like a scope capture type of program, but it is in fact capable of decoding CAN messaging. And for that sort of money, what you can do is you can take individual grabs depending on the speed of your laptop. You can set the sample time and the number of samples, and when you click the start button, you'll get a sample of maybe 1 or 2 or 3 seconds. So this is more like a snapshot tool. It doesn't give you continuous data logging, but it's extremely powerful for the money. And as I said, you can just select one of these channels. This is an 8-channel scope one that we're using here. So we can tell it that channel 0 is actually a CAN channel, and we hang that off our CAN low signal in this case. And this will just read the CAN data, decode it, show us the address channels, the data channels, and so forth. And this tool allows you to scroll through these messages. Again, it's a snapshot tool, so you can only collect 1 or 2 seconds worth of data, but it's certainly a very useful tool, especially for the sort of money. And of course, it's a general purpose data analyzer as logic analyzer, so it's just a very, very handy tool indeed. Okay, now another way you can look at CAN data, I've sort of headed from the best to the most expensive to the least expensive tool here. Many of you will have OBD Scan tools, and there's a picture of one on the right. This is one that we use here for the odd application. This is just simply a USB to OBD adapter, and this works with a lot of free type OBD software. But what people don't realise is that the same device does have some basic CAN monitoring capabilities as well. Now they're not a very fast device, and so the example I've shown in the bottom of the screen is just some live CAN data, if you like. Now what you can see here is there are a lot of data errors, and this is simply because the device isn't fast enough to keep up with the data on the CAN bus. So this is not a high reliability device, but of course these are very inexpensive tools. You can buy them on eBay for $30. And as long as they use the ELM format, which is the standard, if you like, the standard sort of low-cost CAN diagnostic format for OBD, then you can just download the data sheet from the ELM website. There's a link there, and it'll tell you how to control this. What I've done here is I've just simply used RealTerm, which is a terminal program we use all the time. Put in a few commands as I've detailed here. ATI, which just identifies the device. ATSP6 sets the speed to 500k CAN. And ATMA, which is the monitor command. So when you do these 3 commands into this device, it'll just be hanging on the CAN bus, and you can immediately start to see some of the messaging. So I stress that this is some of the messaging. It's not usually fast enough to keep up with all the messaging, so that's why you see these data errors, but nonetheless you can still get an idea of what's going on. On the left we have the address, and then we just have the 8 data bytes. It's very straightforward, but this again is a very useful tool, especially at the price point. And if you need to get some basic CAN information, then this is not a terribly difficult way to go about it. Okay, now that concludes this webinar. Thank you very much for attending. Now you may, of course, as I've mentioned, we do have many other webinars on our website, and I detailed 4 of those earlier on that we would suggest you take a look at. We also have the Motek forums. Now this is where many of our users and also many of our support staff and engineers are active. And so there are topics which cover all of the Motek products, all of our software applications, and some of our specific things such as PWCs and so forth. So this is a very useful forum to take a look at, and you can interact with other Motek users and again with us, the support staff here, and some of our engineers.